Welcome to Tutor-E's Chemistry Hub, where we'll do our very best to show you how simple chemistry can be, and in the end, make you better in chemistry. Continue our discussion regarding stoichiometry. Just looking at this question alone, and having watched the introductory video on stoichiometry, it is easy to read and just see that this is mass to volume relationship. As you can see the question, 6.35 grams of copper. Grams refers to mass. Reacts completely with triazonitrate 5 acid. However, you have to calculate the volume of nitrogen 4 oxide produced. So you see, you are given mass and you have to use to calculate volume. That means mass to volume relationship, which is a type of stoichiometry. So we are going to see exactly how we solve this kind of question. So the first thing, as usual, let us rewrite the chemical equation. Copper reacting with nitric acid. Normally, I'll just point this out here. However, hopefully when we do subsequent videos, where we're going to do metals and their properties, this becomes understandable. Copper does not react normally with acids because it is lower than hydrogen in the electrochemical series. However, because triazonitrate 5 acid is a very good oxidizing agent, it is able to do so in this case. And because you're having nitrogen 4 oxide, that shows that this is actually concentrated triazonitrate 5 acid. If it was nitrogen oxide, that's NO, that would have signified that it is diluted triazonitrate 5 acid. But that's not what you're looking at here. I just said, let me take a detour. So let's focus on stoichiometry. First thing, we have read the question, and we already know that we are dealing with copper. We are given the mass of copper, and we have to calculate the volume of nitrogen 4 oxide. So those are the only two things that we need. So we simply have Cu, and then we have 2NO2. First thing first is we get the number of moles. Next is we get the molar mass. But remember, we are dealing with molar mass in the case of copper, and then we are dealing with volume in the case of NO2. So in that case, we will not calculate the molar mass. We only need the molar volume, which we have been gladly given right here as 22.4 dm cube. And then we are going to guess the mass, which is simply the number of moles from here times the mass of volume that we get from here. Again, it's either mass or we can call it volume in the case of NO2. The number of moles, copper is just 1. NO2 is 2. That's the number behind. The molar mass, copper is 63.5. And NO2, you can see now you don't calculate the molar mass because you are not dealing with mass. You need the volume, so you just need the molar volume. And we are giving us 22.4 dm cube. Again, it is because this is at STP, but there may be questions where you have the volume at ROTP, which is practically room temperature. And in such cases, most times it is 24 dm cube. So always check a question, check the conditions, and most times again, the volume at such conditions will always be specified. So now the mass of copper, number of moles, which is 1 times 63.5, we have 63.5. And then for the volume of nitrogen 4 oxide, 2 times 22.4 gives us 44.8. So that is always the first step of calculating any question. You extract what you have from the chemical equation. So now we know 63.5 grams of copper produced 44.8 dm cube of NO2. The question now says, how much will 6.35 grams of copper actually produce? So therefore say 6.35 will produce X. We don't know the amount. Cross multiply. So we have 63.5X equals 6.35 times 44.8. So therefore X equals 6.35 times 44.8 divided by 63.5. Again, you can use a calculator to get the answer. However, if you are familiar with this, 6.35 divided by 63.5 will give you 10. Then 10 dividing 44.8 will give us 4.48 dm cube, which is decimeter cube. And then you remember, if we wanted our volume in centimeter cube, the volume is the value in decimeter cube times 1000. So our value will simply be equal to 4.48 times 1000 will give us 4,480 centimeter cube. So it all depends on what the answer is given in. If it's decimeter cube, 4.48. If it's centimeter cube, you have 4,480 centimeter cube. So that was question number 1. Pretty easy. Just be able to decide what kind of question it is. What kind of question it is, what kind of stoichiometry it is, and that tells you exactly how you have to calculate it. Now the second question says, an excess of a divalent metal is dissolved in the limited volume of hydrochloric acid if 600 cm cube of hydrogen were liberated at STP. Again, STP. Determine the mass of the metal produced this volume of hydrogen. So you can see we are dealing with the mass of the metal. That means we need M, and then the volume of hydrogen produced. So the first thing we simply do is we have to craft out the chemical equation. The metal M reacted with hydrochloric acid, which is HCl, to produce. Now I'm not putting the states of matter in this case because for what we need it's not really necessary, but you can know that the metal will be solid. Hydrochloric acid will be aqueous because it is dissolved in water. Now to the main point. Whenever a metal reacts with an acid, you are going to be having two products. Basically, metal plus acid. You have two products, and that is a salt and you have hydrogen gas. Always your two products. Now, how do you get the salt? It is simply the metal pushing out hydrogen from the acid. So if you have M, it means M would displace hydrogen. And then M obviously is going to be standing with Cl. However, you have to be careful in this case to get the proper formula of the salt. Check out my earlier videos on balancing chemical reactions. There were some specific questions where we had to bring out the proper formula of each compound. So when you check out that video, you will know exactly how to get the formula of compounds when you are not given. Because if we should write MCl, our answer is going to be wrong because we have used the wrong formula of the metal. So it is quite important. So how do you know the proper formula? Well, they said the metal is divalent. Divalent means di basically means 2, and valence means the number of electrons in the outermost shell. So most times it will be written as M2 plus because metals are likely to lose electrons. But for what we need, we are okay with M2. And then for chlorine, the valency or oxidation number is simply 1. When you swap it, you have M1Cl2. But we don't need to write 1. So the proper formula is MCl2. So therefore, our salt is actually MCl2. Remember, hydrogen gas is liberated. So H, and then hydrogen is always diatomic. So there has to be a 2 here. So this is your proper chemical equation. The next step, again, as I said in our introduction to stoichiometry, the reaction, you must make sure it is balanced. So the next step is to balance the chemical equation. Again, check out that video and you see exactly how to balance chemical equations. However, in this case, it is simply to place 2 moles in front of hydrochloric acid, and then our equation is balanced. Now that it is balanced, we can go ahead to actually solve the question that we are given. Again, before I proceed, I'll just point something out. Just in case, even if you didn't read about the part that says divalent metal or you forgot about it, a secret you can have here is you are given the molar mass of the metal as 24. And if you check it out, which metal has a molar mass of 24? It is actually magnesium. So if you're having magnesium chloride, what is the formula for magnesium chloride? It is MgCl2. But you just have to remember, this was to help you get the proper formula. But when writing it or answering the question, you use just M and not actually Mg. All right. So now we have gotten our chemical equation. Now we'll move on to our calculations. As we have already determined, we need M and we need hydrogen. So we'll bring them out. M and hydrogen. First, the number of moles, then the molar mass, and again, because we are dealing with molar volume, we get that, and then we get the mass or the volume. All right, so for the metal, the number of moles is 1. For hydrogen, the number of moles is 1. The molar mass of the metal, we are given as 24. The molar volume of hydrogen, because we are dealing with volume, we take the molar volume of hydrogen, and 1 mole of any gas is always 22.4. And then our mass becomes number of moles times the mass, which is 1 times 24. That gives us 24. And then 1 times 22.4 gives us 22.4. Again, remember, after the equation is balanced, the next thing you have to do, extract the information that you are given from the chemical reaction, and then you apply the question. So now we can say, if 24 grams of M produced 22.4 dm cube of hydrogen, the question asked us, how much of M will produce 600 cm cube or centimeter cube? Again, remember, when calculating, your units need to be uniform. You are given the value as 600 centimeter cube. So you have 2 options. It is either you convert 22.4 dm cube to centimeter cube, so they are uniform, or you convert this centimeter cube to decimeter cube. But the key is they must be uniform. Since I already started with 22.4 dm cube, I'll be converting 600 centimeter cube to decimeter cube. And you just remember that in decimeter cube, it is the value in centimeter cube divided by 1000. So that simply means 600 divided by 1000, and that gives us 0.6 dm cube. So therefore, I won't be using 600. I'll be instead be using that it is 0.6 dm cube of hydrogen. But if you convert it to centimeter cube, that means you'll be using 22,400 centimeter cube and not 22.4 decimeter cube. So from here, you simply cross multiply, and then you have that 22.4x equals 24 times 0.6. So therefore, x equals 24 times 0.6 divided by 22.4. And if you should simply calculate this, you have 24 times 0.6 divided by 22.4. That gives 0.643 grams. But it's actually 6.64285, but approximated in this case to 3 significant figures. And that is simply your answer. So it is quite simple. Remember, the key is always know the type of stoichiometry and know what exactly you are given and what you need to calculate for. Check out again the video on the introduction to stoichiometry and you get this picture very clearly. Check out how to balance chemical reactions and you get how to get the proper formula of compounds. And as always, remember to like, share, and subscribe if you do find this helpful.